All right, this lesson we're going to go over the product rule and the quotient rule, which is also going to allow us to derive the formulas for secant and tangents, the derivatives of those trig functions. All right, so product rule, unlike limits, you cannot just do derivative of f multiplied by derivative of g. Wish it were that easy. Instead, you're going to apply this rule. So you're going to do the derivative of f multiplied by regular g, and then plus regular f multiplied by the derivative of g. All right, so you do the derivative one at a time, and then you multiply by the non-derivative of the other function, and then that's it. Okay, so let's do an example. So this is a product between x cubed and cosine x. Actually, I want to show y'all one other way to write this because I like to write it this way because it's a little cleaner. So derivative with respect to x of u multiplied by v. So that's u prime v plus v prime u. Okay, it's the same thing. I just use different letters. All right, so I use different letters because above this, I'm going to write a u for x cubed. I'm going to write a v for cosine x. This uv notation will come back later in the year. So I kind of want y'all to get used to that as well. All right, so y prime, derivative of y is equal to, so we do u prime, which is 3x squared, times v cosine x, plus u, which is x cubed, times derivative of cosine x, which is negative sine x. All right, this could be a product. You could say u is 2 and v is sine, but that's doing too much. All right, you do not need to do a product rule here. A product only counts if you have a function in terms of x. So an x here and an x here. 2, while technically a function, is not a function of x. It's just a constant, and we treat constants a little differently. So this one, you do not need a product rule. You just have minus 2, because remember, when you take the derivative of a constant multiplied by a function, that's equal to the constant multiplied by the derivative of the function. So you just remove the constant. That should be an x in there. So you just remove the constant, negative 2, and you take the derivative of the function part. Derivative of sine is equal to cosine. All right, I'm just going to clean this up a little bit. So y prime is equal to 3x squared cosine x minus x cubed sine x minus 2 cosine x. All right, quotient rule. So same deal, you are not allowed to simply say derivative of f divided by derivative of g. Wish it were that easy. Okay, this is the quotient rule. You do g prime times f minus f prime times g divided by g squared. All right, we have a little saying to help you remember this one. It's low d high. D high means derivative of the numerator, minus high d low divided by low squared, or low times low if you prefer low times low. All right, that kind of looks like a 10. Hold on. Let me bust my eraser out here. I'm going to change my L's so they look like L's instead of 1s. All right, so low d high minus high d low divided by low squared. All right, so we have a quotient right here, function on top, function on bottom. So we do low, which is x cubed, d high, derivative of sine is cosine, minus high, which is sine x, d low, which is 3x squared, all over low x cubed squared. Okay, we can do a little bit of simplifying here. Usually when you do quotient rule, you'll be able to cancel something out. I shouldn't say usually, but oftentimes you can cancel stuff out. So I'll do 2 steps. So I'm going to rearrange a little bit here. So this is x cubed cosine x, and then minus 3x squared sine x, just writing that in front. And then this one we'll evaluate is x to the 6th power. All right, and so see how they all have x's. They all have an x squared, in fact, so we can cancel out the x squared. That'll turn this into an x to the 4th power, That'll turn this into x to the first power, so just x. So our final answer would be x cosine x minus 3 sine x divided by x to the fourth. All right, I would, well, you can try this on your own. It is a little bit challenging, I will say, but I think you could do it. So give it a try on your own and come back and see how you did. All right, so I'm going to rewrite this. The denominator is x to the 1/4 power. I want to be able to use my power rule when I take the derivative of that part. So I'm rewriting it like that. All right, low d high. So low is x to the 1/4 power. D high is 2x, because the plus 2 goes to 0 when we take the derivative. Minus high is x squared plus 2. D low, all right, 1/4 x to the negative 3/4. All over low x to the 1/4 squared. Okay, so that's it. I mean, this is the answer, but there's a few things wrong with leaving this as our final answer. We do have a negative exponent right here. And then when we fix that problem, it's going to create a complex fraction problem. So you're almost always told, do not leave negative exponents in your answer. Do not leave complex fractions. And we follow those rules because on the AP exam, our multiple choice answers are going to follow those rules. Okay, so the hard part of this problem is the simplifying. It's really the algebra. That's all we're doing here. So we've done the calculus part. Calculus is over. So we're just doing some algebra now until we get an answer that is simplified enough to where we can match it with an answer choice. Okay, so I'm going to do a few things here. I'm going to multiply these together. I add the exponent. So this is a 2x to the 5/4. I'm going to, all right, I'm not going to distribute. So what I'm going to do is I'm going to move my negative exponent to the bottom with the 4, and then I'm going to put this thing on the numerator right there. So we're going to have our minus sign. Then we're going to have x squared plus 2 on top, because that's multiplying by 1. And then on bottom, we're going to have 4x to the 3/4, moving that x to the 3/4 down. And then on the big denominator, power to a power, we multiply, so that's x to the 1/2. I think I might leave it as a 2/4, actually. You'll see why in a second. Okay, so we took care of the negative exponent problem, but now we have a complex fraction, and we're not supposed to leave complex fractions either. So to get rid of our complex fraction, we are going to multiply by this denominator right here. So we're going to multiply by 4x to the 3/4. And whatever we do to the top, we have to do the same thing to the bottom, 4x to the 3/4. Okay, so now we are going to distribute. This distributes here. This distributes over here. Okay, and I'm trying to think of the best way to write our answer. Oh, no, we're good. Okay, never mind. I was trying to make it too hard. Okay. All right, so when this distributes over here, you get 4 times 2, which is 8. X to the 3/4 times x to the 5/4. You add those exponents. Well, 5/4 plus 3/4 is 8/4, which is just 2. So that's x squared. And then when this distributes here, they cancel with the denominator. That's why we multiply by this thing. And so we just have the minus, and then this should really be in parentheses. I don't need to write parentheses when it's in fraction form like this. But now that the fraction's canceling out, I need to make sure to put parentheses, or what I'm going to do, go ahead and distribute the minus sign in there. Minus x squared minus 2. Then my denominator, I have 4 times 1, so 4. And then x to the 2/4 multiplied by x to the 3/4. That's why I wanted to leave it, because it has a common denominator, so that's going to be x to the 5/4. All right, that looks much better, much cleaner. We have one more step. Just combine these like terms up here. 7x squared minus 2 divided by 4x to the 5/4. Okay, and again, if you're doing a multiple choice question, that's what your multiple choice answer would look like. And if you're working in the textbook and looking at answers for the odd questions, your answer is going to be simplified like that. So That's why we want to still practice our simplifying, even though that's not technically calculus what we just did. It is still math that you need to know how to do. Okay, the next part is just talking about how using the quotient rule all the time isn't always useful. It works, but certain problems would be easier to not use the quotient rule. Okay, so we can use the quotient rule here, low, d high, and the numerator is a constant. So if you take the derivative of a constant, you get 0. So that's just going to zero out that part of the quotient rule. Okay, and so anytime you have a constant on the numerator, don't use the quotient rule. Rewrite your function. So this can be rewritten as 9 over 5 times x to the negative 2 power. Then you can just use the power rule, multiply by negative 2. So that's going to be negative 18 over 5, x to the negative 3 power. And then you're going to get rid of your negative exponent by moving it down to the bottom, negative 18 over 5x cubed. All right, and just to show you that it still works the other way, but this way is so much better. So low would be 5x squared, d high would be 0, minus high, which is 9, d low would be 10x, all over 5x to the 5x squared squared. All right, so that's 0. This is negative 90x. This is 5 squared is 25. Power to a power is x to the 4th. Okay, so we're not quite to where our answer is over here. That's because we can simplify. This x cancels with one of these x's, leaving us with x cubed. And then 90 and 25 are both divisible by 5. So if we divide by 5, we get negative 18. Divide by 5, you get 5x cubed. Same answer, but a little bit more difficult. Certainly bigger numbers that you have to deal with. Okay, so the other thing we're going to use the quotient rule for is to derive a rule for the derivative of the other 4 trig functions. So we're going to start with tangent. And so if we're going to use the quotient rule, we need to rewrite tangent as a quotient. And we know that from our pre-cal class that tangent is sine x divided by cosine x. All right, so now we are just going to apply the quotient rule that we just learned. Low, d high. Low is cosine x. D high is cosine x. Minus high d low, so high is sine x. Multiplied by d low is negative sine x. All over low squared, cosine squared x. All right, so up here we get cosine squared x minus, and actually it's a negative times a negative, so plus sine squared x all over cosine squared x. And you should recognize this numerator. It's written backwards, but with the plus sign, it doesn't matter which way it's written. Sine squared plus cosine squared equals 1. And then this is another identity you should recognize. 1 over cosine is equal to secant squared x. That is the derivative of tangent. Derivative of tangent is secant squared. Hold on, I'm going to pause. All right, so we'll derive secant as well, and then I'm just going to tell you what the other two are, but the other two would work in a very similar fashion. All right, so secant is 1 over cosine. So we're taking the derivative with respect to x of 1 over cosine x. All right, so we get low d high. This is one, so I just said, like on the last page, if there's a constant on top, make it a negative exponent, use the power rule. So that doesn't work as well here. First of all, if we did that, you would need to know about the chain rule, which some of you might know what the chain rule is already, but right now we're pretending like we don't. So we're not going to use the chain rule. We are going to use the quotient rule that we learned about here. Just because we don't have just an x on the bottom, we have a whole function, cosine of x on the bottom. So that's why it's a little different. All right, so back to quotient rule. Low, d high. Low is cosine x. D high is 0 minus high d low minus 1 times derivative of cosine is negative sine x all over low squared, cosine squared x. All right, well, this first term we get multiplied by 0, so that cancels out. And then I have a negative times a negative is a positive sine x. And then I have my cosine squared x. All right, so what you are going to do here is you're actually going to split this into two fractions multiplied together. So this is going to be, one of them is going to be a sine x over cosine x. And then the other one's going to be a 1 over cosine x. And then if you convert those using the identities that you know about, sine over cosine is tangent, and 1 over cosine is secant. And then just in math, we usually write this the other way around. So we write it as secant tangent. And that's it. So the derivative of secant is secant tangent. Okay, so we're just going to record these down here. So we have secant squared x for derivative of tangent. We have secant tangent for the derivative of secant. Cotangent is negative cosecant squared x. So you can see how it's kind of related, right? It's the cosecant instead of the regular secant, and then it's negative instead of positive. And so cosecant, going to kind of be similar. It's going to be negative, and then it's cosecant x, cotangent x. So these all have the cos attached to them, and they have negatives. These are the regular positives. Okay, so this whole deriving process is just to show you where these formulas come from, so they don't seem like they're magic formulas out of nowhere, because they're not. Nothing in math is magic. It's all been worked out before. Okay, but now that we know the formulas, we are going to just use them. We're not going to go through this whole quotient rule process every time. That would take way too long. All right, so there are things in math you just have to memorize because they're going to make your life easier and it's going to make the problems go by faster. All right, so last problem, second to last problem. We have a product, 3x squared multiplied by tan x. So we use our u-v notation. U is 3x squared, v is tan x. So we're going to apply the product rule. Derivative of u is 6x multiplied by v, tan x, plus u, which is 3x squared, multiplied by the derivative of tan x, which we just learned is secant squared x. Okay, you could factor out a 3 and factor out an x, but that doesn't look any more simple than this looks. So I think we're good to go. We're just going to leave our answer like that. All right, last one. This is a very AP exam type of question where they don't even tell you what the functions are. All they do is tell you a few pieces of information up here about g and h, and then they give you an f function and tell you to find the derivative of it at a certain point. Okay, so the point of this is to force you to do the product rule. Okay, there are ways, if they give you a problem like the one we just did, that if you have a CAS calculator, you could do it in the calculator. Okay, they could probably put it on the non-calculator part, but still, these are the type of questions that they really like asking about because it really forces you to know how the product rule works in and out and to be able to use all the information that they've given you. All right, so we need to find f prime of 2. Okay, so basically I'm going to plug in 2 every time there's an x just because I don't want to write it out twice. Okay, so you do, this is u, this is v, product rule. So u prime is g prime times h. And I just said I was going to write 2 and I forgot. All right, g prime of 2 times h of 2 plus h prime of 2 times g of 2. Okay, and then hopefully they've just given us all the pieces that we need right up here, and they have. So negative 4 for g prime of 2. H of 2 is negative 1. H prime of 2 is 5. G of 2 is 3. So this is 4 plus 15, which is 19. All right, hope you enjoyed the video, and we'll see you on the next one.